Oh, sorry. Let me turn down my my music here. I gotta turn this off. Sorry, I'm just listening to some Rihanna. Welcome to this video. This is a video on work. Okay, and the objective is to solve work problems, contextual problems, using rational equations in the foundation that we've done so far in this unit. All right, so without further ado, let's go ahead and let's get into this concept of work. So I just need to define a couple of terms first. Work, this is the number of jobs to be completed, okay? So if I have to paint one room, that's one job. If I have to mow one lawn, that's one job, okay? Rate, that's how fast that you can actually do something, right? The rate at which you do that job, okay? And that's always going to be a ratio, and that's important too, okay? Always going to be a ratio. And then time, okay, that's how long someone is working to complete the job, okay? So we get this equation here. We get work equals rate times time. Work equals rate times time, okay? So the next part, solving the equation work equals rate times time for rate yields the following definition. So now if I use inverse operations to isolate the rate, we get rate is equal to work over time. Now work generally is one job completed divided by the time it takes to complete the job, okay? And we're going to use this definition to write expressions for rate, which are often called work problems. So the first example here, let's look at how to write expressions for rate. So number one, it says if Carlos can mow the back lawn in 30 minutes, what is his rate? Well, how many lawns is Carlos mowing? Well, his rate is equal to one lawn mowed, okay, over 30 minutes. Okay, so that's his rate, right? One over 30. Okay. All right, number two, if Samantha can paint a new shed in 5 hours, what is the rate at which she paints the shed? Well, again, how many jobs is she doing? Well, she's painting one shed. Okay, and what's the time? 5 hours. Okay, so her rate is one shed every 5 hours. Or if we wanted to do it just per hour, right? This is 1/5 of the shed every hour. Number three, if Thomas can run a mile in 7.2 minutes, what is his rate? Well, how many miles is he running? One. How long does it take him? 7.2 minutes. Okay, and if I divide those, that's about 0.14 of a mile is ran each minute. Okay. All right, so that's how we identify rate, right? The number of jobs divided by the time. Okay, so let's go ahead. I'm going to get into this example here. Okay, so example number one, it says water is flowing through both a small pipe and a large pipe, can fill a water tank in 9 hours. Water flowing through the large pipe alone can fill the tank in 17 hours. How much time t in minutes would it take to fill the tank using only the small pipe? So they give us some information, and it's important to go ahead and kind of highlight the key information that they give us. Okay, so note that it says water's flowing through both a small pipe and a large pipe, and I want to change this. Here we go. So a small pipe and a large pipe, and it can fill it in 9 hours. Okay, water flowing through the large pipe alone. So a large pipe alone can fill the tank in 17 hours. How much time t in minutes would it take using only the small pipe? Okay, so how much time would it take using only the small pipe? So what we want to do is we want to write some rates for all of these situations. Okay, and the first information they give us, it says both the small pipe and a large pipe. Okay, so note that the them working together, they can do it in 9 hours. So that is 1/9. Okay. Now, if the large pipe is working alone, it takes the large pipe 17 hours. Okay. Now, what's the rate for the small pipe? Well, we don't know how much time it takes for the small pipe, so that's 1/t. Okay, so those are the rates for each of those individual pieces. Okay, and then what we want to do now, it says step 2, write an equation to solve and then answer the question. So what we have here is, if I have a large pipe working alone, it takes 1/17 hours. You agree? Okay, plus the small pipe, it takes 1/t. Okay, and that's in hours. It's important that that is in hours. Okay, equals 1/9 hours. Okay, so those are that's our equation for this example. Now what we want to do is I want to solve this. Well, how do I solve a rational equation? Multiply by the LCD. So what is my LCD? Well, I'm just going to multiply by 17 times 9 times t, right? You agree that each of these pieces is a factor of our denominator? Okay, I'm going to multiply by 17 times 9 times t. Over here, 17 times 9 times t. Now, what happens? Well, some stuff is going to cancel. I have 17 cancels here. Okay, and then this produces, let me go down here. Got to erase it the old-fashioned way. Okay. That's weird. Picture of me just, let's do this. Bye. Okay. All right, so then we have 9t plus over here, t cancels, and we get 17 times 9. So 17 times 9 is going to give us 153, which is equal to, now I'm going to reduce the 9, okay, and we have 17t. So I can solve for 17t by subtracting 9t on both sides. Okay, and we get 8t is equal to 153. So we'll solve by dividing both sides by 8. Okay, and you get t is equal to 19.125. So it's important to note that this is in hours, right? That's what our initial problem was in. Okay, so what we want to do is we want this to be in minutes. So how do I convert from hours to minutes? Well, how many minutes are in 1 hour? 60. I'm glad you said 60. You're very smart. Good job. Okay, so we'll go ahead. We'll multiply this by 60. Don't round. Do not round this at all. Keep it as is. Okay, and we get 1,147.5 minutes. Okay, this is a word problem, so we have to give an answer in words, and our answer is, it will take 1,147.5 minutes for the small tank, the small pipe to fill the tank. Okay, and there is your answer. All right. That's going to do it for this video. This is part A. Go ahead and watch the second video. I'm going to cover another example similar to this, and then we will also look at a couple of practice problems. Catch you next time. Peace. Hey, welcome back. We're talking about work. Welcome back. This is part 2 of the video, and in this video we're gonna finish off the second example in your notes, and then we'll have 2 practice problems. Okay, so we're talking about work, and in the first example here it says Nathan can paint a room in 8 hours, and his brother Jonathan would need 12 hours to paint the same room. If they work together, how long will it take in hours to and minutes to paint the room? So I'm going to go ahead and I'm going to write down the individual rates, right? So I know that it takes Nathan 8 hours, so that's 1/8. That's his rate. Okay, I know that it takes John 1/12 hours. He paints 1/12 of the room in an hour. Okay, how long will it take if they work together? I don't know. So I'm going to use a variable, t. Okay, and this gives us an equation, right? If Nate's painting, that's his rate, and if John's painting, that's his rate. If they work together, that is 1/t. Okay, so I want to solve this. So what we can do is we'll go ahead and multiply by the LCD. In this case, actually, your LCD is going to be 24t. Okay, that's your LCD. You can still multiply by 8, by 12, and by t. 8, 12, and t. So if you struggle with identifying the LCD, feel free to just multiply by all of the denominators, and everything will cancel out, right? But if you're quick with the LCD, you're like, hey, 24t will do the job. That can make your math simpler. So I'm just going to do it this way. Okay, so I have 8 cancels here, 12 cancels here, and t cancels here. So we get the equation 12t plus 8t is equal to 8 times 12, and that is 96. Okay, so 20t is equal to 96. And now if we divide by 20, we get t is equal to 4.8. And it's important to note that this is in hours, okay? The problem wants to know how long will it take them together in hours and minutes. Hours and minutes. So what we can do is, I know the hours, right? I know it takes them 4 hours. So we can say if they work together, it will take them 4 hours and how many minutes? Okay, well, I know that there's 4 hours gone. Okay, so what I want to do is I want to take 0.8 hours, okay, and I want to multiply by 60 minutes. I want to convert from hours to minutes, okay? So my hours cancel, and when we multiply 0.8 times 60, we get 48 minutes. Okay, so it will take them 4 hours and 48 minutes to paint the room. All right. Okay, so that's it. That is work problems, right? You construct the rate, the jobs divided by the time it takes. You make an equation, and then you solve that equation with those individual rates. Okay, so that is the last example. I would like you guys to go ahead and try these 2 practice problems. So here's the first one. Go ahead, please pause the video, attempt this problem, and then I'm gonna scroll up and you can see the solutions, okay? Pause it. All right, I'm glad you put in that work. Okay, and here is your answer. It will take Laura, if she works by herself, 9 hours, 20 minutes to clean that fish tank. Okay, that's a long time. That's a pretty big fish tank. You think about it. She must, yep, it's an aquarium tank. Okay, all right, and then here is the second practice problem. We're talking about burning garbage, okay, an incinerator. Okay, so go ahead, pause the video, attempt this problem. All right, hopefully you pause the video and you've attempted it. Here is the solution. If both incinerators are working, it will take about 8.2 hours to process a day's garbage. All right, that's it for this video on work. Go ahead, give me a thumbs up. This was a good video. Yes, or good too, okay? Until next time, be easy, work hard, okay? See you later.